For the first time, a single document brings together comprehensive data on how micro and nanoplastics spread through the biosphere, enter food chains, and harm human health and ecosystems. The report is the result of an extensive interdisciplinary analysis that encompasses ecological, climatic, medical, physical, and chemical aspects of the harmful impact that micro and nanoplastics exert on the biosphere and human health.
The global threats facing humanity require united international action. And today, we have a clear direction. Thanks to the scientific group of ALLATRA, we not only recognize a problem, but understand its underlying physical nature, the electric charge that gives nanoplastics their destructive power. By addressing this cause, that is, by removing that charge and disarming the killer, we can give the biosphere and ourselves a chance to prevail. So we must use the time we still have. And this is not an exaggeration. Our cognitive abilities are rapidly declining, and this is serious. It is a result of nanoplastics accumulating in our brains. You may already notice it in yourself and those close to you. Unless we act, it will only worsen year after year. And now, you will learn why.
The age of intellectual extinction. Throughout the 20th century, scientists observed a trend. Since 1932, IQ scores had been steadily rising. This phenomenon became known as the Flynn effect. However, among generations born after the 1970s, the rise in IQ has reversed to a gradual decline. Mandatory IQ tests for military personnel in various countries show a decline in scores since the mid-1990s. According to another study conducted between 2006 and 2018 at Northwestern University, Americans showed a decline in IQ across 3 out of 4 cognitive areas. This decline in average IQ has been termed the reverse Flynn effect. In 2025, the scores of U.S. high school students on major math and reading tests dropped to the lowest levels ever recorded. Their average math score was the worst since the current version of the test was introduced in 2005, while reading scores were the lowest since testing began in 1992. Similar trends have been observed in other countries. The steady decline in IQ continues to this day. Intelligence scores are no longer rising. They're slowly, but surely falling. But what lies behind this troubling trend? One important correlation stands out. The decline in average IQ coincides with the exponential rise in plastic production and pollution. Take a look at the graphs. The more plastic, and therefore the more micro and nanoplastics in the environment, the lower the IQ. This shows a clear link between increasing the amount of plastics and declining cognitive abilities. And that is deeply alarming. This isn't just a statistical correlation. As plastic production has skyrocketed, our daily exposure to micro and nanoplastics has risen with it. Charged plastic particles can easily pass through biological barriers, including the blood-brain barrier. Once inside the brain, nanoplastic particles accumulate not only in neurons, but also in glial cells, the very cells that nourish and protect neurons and help form neural connections. There are many more glial cells in the brain than neurons themselves. Electrostatically charged nanoplastic disrupts the function of glial cells, triggering inflammation and chronic stress, setting off a continuous cycle of destruction inside the brain itself. For the brain, chronic stress and inflammation are like a computer running on a critically low battery. When the battery is nearly drained but dozens of programs are still running, the system automatically switches to power-saving mode, shutting down energy-intensive applications to avoid overheating or freezing. Our brain works in a similar way. When stress and inflammation reach a critical point, the brain, like a computer, will eventually shut down its most energy-demanding regions to survive and conserve energy. The first to go offline is the prefrontal cortex, the youngest and most complex part of the brain. It's considered the control center, responsible for such essential functions as intelligence, behavioral regulation, and the ability to think logically, consistently, and rationally by comparing facts and drawing conclusions. The most dangerous part is that the shutdown of the prefrontal cortex happens silently, without our awareness, and we won't even realize it. The brain will switch to its basic survival programs. The ancient rapid response system, the limbic system, takes over. Its key structures, the amygdala and hypothalamus, trigger the fight, flight, or freeze reaction, fast, impulsive, and without time for reflection. These systems will still stay active for a while because the brain identifies them as critical for survival. As a result, rational decision-making gives way to panic. Creativity and intelligence are replaced by degradation and dullness. Empathy fades, replaced by indifference or aggression. Electrostatically charged plastic particles that enter the brain interact with neuronal membranes, activating microglia and continuously fueling oxidative stress and chronic inflammation. Prolonged stress literally reshapes the brain. In the prefrontal cortex, the center of analysis and control, neural connections weaken and disintegrate. Similar changes occur in the hippocampus, the region responsible for memory and learning. Neural connections fade away, and the hippocampus deteriorates. In the amygdala, the centers of fear and anxiety, the opposite happens. Connections strengthen, anxiety and aggression intensify, and panic attacks may develop. The brain reorganizes itself. Instead of thinking and analyzing, it starts operating on instincts. In doing so, it loses the ability to recognize real danger and respond appropriately. This isn't a temporary reaction. It's a fundamental restructuring of the brain. The capacity for learning, cooperation, and rational decision-making declines. This may help explain global trends we see today in society. A decline in average intelligence, a rise in anxiety and depression, an increase in aggression, impulsivity, and issues in social relationships. As the amount of plastic in the environment continues to grow, the reverse Flynn effect will only become more pronounced. People won't just become less intelligent, they won't even realize it. They'll become captives of a reality distorted by their own brains. As a result, humanity will lose the ability to perceive the world, events, and even obvious threats adequately. They'll no longer be able to connect facts logically, and therefore will lose the ability to make sound decisions. That will mark the end of human thinking.
Our cognitive decline is already underway. This is not a prediction, but reality. Plastics are making us less intelligent and less capable of responding to crises. They're damaging the regions of the brain that are responsible for memory, attention, problem-solving, and creativity. The very abilities we urgently need to achieve scientific breakthroughs and to find a way to neutralize the threat posed by micro and nanoplastics. And we have very little time left to make the right decisions. Yet, the loss of intelligence is not the worst that awaits us. Prolonged exposure to micro nanoplastics and their accumulation in the brain that leads to gradual failure of even our most basic survival functions. In other words, we risk losing not only our ability to think, but our very ability to live. And if that sounds like an exaggeration, consider the bees. Because their body mass is much smaller, the concentration of plastics in their brains is much higher. They already live in the world that we are now rapidly entering.
Microplastic can enter a bee's body through its thin cuticle, or along with food. And within just 72 hours, it reaches the brain. From there, as in humans, it triggers synaptic damage, neuroinflammation, cell death, and neurotransmitter disruption. The bee loses body mass, its metabolism slows, and its immunity weakens. Its sense of smell, memory, and navigation begin to deteriorate, and bees stop recognizing their own colony and can no longer find their way back to the hive. With prolonged exposure to nanoplastic, the damage becomes fatal. The bee's nervous system collapses under the strain, and some simply drop dead in mid-flight.
Look at this photo. You can see the brain of a bee that has been penetrated by nanoplastics. This amount of nanoplastics was enough to cause serious cognitive impairment in the bee. What is a critical point beyond which, like the bee, we stop recognizing the world around us and die on our way home? If nothing changes, this is a future that awaits us.
It's also important to acknowledge that there is no safe level of these chemicals in the body. So while the manifestation may take time at a lower dosage, it is not immune, that at lower dose it's safe to have that. And why is it important? I think it's important for so many reasons, because as soon as we define the threshold, various special interest groups would argue to keep micro nanoplastic concentration below that level, whether it's in soil or in water or whatever that is. And what does that mean? Is that we are allowed to have some degree of micro nanoplastic in our sources, air, soil, water, and so forth. But it's a cumulative impact, we have to remember. It's not a particular threshold at any given point in time in the source of whatever we are consuming, but it's a cumulative impact in our brain. And we don't know that, honestly, because it's the factor of time there is going to be different for bee than for a young child who doesn't have a fully developed brain versus an adult brain.
Let us recall that a single nanoplastic particle in the human body is not equivalent to one dead cell. After destroying one, the same particle does not stop. It continues traveling through the body, killing one cell after another. So even the tiniest amounts of nanoplastics will damage the brain. And that's why there's no such thing as a safe concentration. And there will never be. The only difference lies in the rate of destruction. That is, the more nanoplastics there are, the faster the process. These plastic particles destroy the biosphere and the cells within our bodies. They damage organelles and biomolecules, including mitochondria and DNA, leading to reduced energy production, genetic mutation, the breakdown of neural connections, and the disruption of brain signals that regulate our organs and vital functions. All of this happens imperceptibly as we go about our daily lives. Yet, inside the brain, a silent systemic destruction is already underway. The question is, will we as humanity recognize the full scale of this threat in time and find a way to strip micro and nanoplastics of their ability to accumulate and retain electric charge?